So in this lesson, we're going to be talking about the relationship of right triangles and similarity. All right. Now, you're going to maybe hear me refer to this as the magic three triangles, and we're going to get into why, obviously, why I say magic three triangles. When you see words like right angle or a right triangle, altitude, and hypotenuse, this is the concept that the question is referring to. All right. So let's kind of break down this magic three triangle stuff. So when you get questions that have to deal with right triangle similarity, you're going to have one big right triangle, and the altitude of that right triangle is going to be drawn so that it creates two more right triangles. Okay. So you're going to have a right triangle here. You're going to have a small right triangle. You're going to have kind of a medium-sized right triangle, if you will. And then you're going to have that big right triangle both of these triangles are kind of in. Okay. So this is what I mean by magic three right triangles. Now I kind of have like a little trick to help you when you're given these magic three right triangles, whatever special right triangle similarity concept questions. All right. All right. So let's throw some numbers. So let's say we have, I don't know, AD is 4, CD is 6, and DB is 8. All right. I lied. Let's say DB is X. DB is what we want to find the length of. Okay. Now, we're going to cover up the 3 first. Now, if you take a look at this little triangle, do you guys see how I'm given 2 of the sides here? Okay. So this is what my short leg is. And then the altitude is what I'm going to call my long leg of triangle number 1. Now, let's cover up triangle number 1 for a second. Now, do you see here for triangle number 2, I have one side and I'm trying to find the second side of the number 2 triangle, okay? This is going to create a special proportion that I'm going to call short leg over long leg is equal to short leg over long leg. Okay, so like in this hypothetical situation, I'm going to do 4 over 6, so short leg of triangle number 1 over long leg of triangle number 1, and then over short leg of number 2. So that short leg of number 2 is going to be that same long leg of triangle number 1. It's going to be the altitude over the long leg of triangle number 2, so X. Okay, and then we just solve it. So X is, I don't even know what X is, 36 divided by 4, I think is 9. Oh, that actually worked out. Cool. Okay, so this is just like kind of like the idea, little tricks that I have of creating special proportions based on these right triangle similarities. Now, remember, when you see these 3 words, sometimes you're going to be seeing, you're going to be given like maybe like a short answer question, and you're going to have to draw a diagram. So whenever you see right triangle, right angle, altitude, hypotenuse, this is what you need to think of. All right. So let's take a look at some more questions. So let's take a look at number 2. In the diagram of triangle DEF, the altitude from right angle DFE has been drawn to DE. If DG is equal to 4 and GE is equal to 8, then which of the following is the length of FG? Now, they don't mention hypotenuse, but however, they do mention the altitude and they do mention a right angle. So this is the right triangle similarity situation. Obviously, we're in the lesson right now, so that's what it's going to be. But again, remember those key words: altitude, right angle, hypotenuse, etc. Okay? So DG is equal to 4 and GE is equal to 8. Now, which of the following is the length of FG? Now, FG is that altitude. Okay? So now remember my little picture like I did above. This is the smaller triangle, and this is my medium-sized triangle. Okay, so I have my short leg and then my long leg of triangle number 1. But now this is my short leg of triangle number 2, and this is my long leg. Okay, so I'm going to do this a similar proportion like I did in my example that I made up above. Okay. So we have short leg over long leg is equal to short leg over long leg. So short leg of triangle number 1 is 4. Long leg of triangle number 1 is x. Short leg of triangle number 2 is x. Long leg of triangle number 2 is 8. Okay, so now we have a proportion. Now we can cross multiply and solve our equation. Now this is a quadratic. Now, how we solve for x is by taking the square root of both sides. So x is equal to the square root of 32. Now, which is not an option for us, but we need to get it into simplest radical form. So let's do that. 1, 4, 9, 16. I believe 16 goes into 32. So I don't know. Let's go over here. So x is equal to 16 times 2. So x is equal to 4 square root of 2, which is choice 1. Okay. All right, so let's look at choice 3. So in the diagram below, altitude NQ has been drawn to hypotenuse NP in right triangles. So there are those keywords that we look for when we're doing right triangle similarity. So which of the following would equal the ratio of MN to NQ? Okay, so here's number 1, here's number 2, and then my big triangle is my number 3. So MN is this one, and then NQ is the altitude or the long leg if you feel so inclined. So MN is the hypotenuse of this little triangle. And then NQ is the longer leg of that little triangle. Okay, so we basically have to go through and see which one could be the hypotenuse over long leg because we want the same proportion, right? Okay, so let's look at NQ over NP. So now NQ is this, so it's the shorter leg of triangle number 2, and NP is the hypotenuse. But since it's not hypotenuse over long leg, that can't be our answer. Now we have NP, which is the hypotenuse of triangle number 2. Okay, cool. To MN. That doesn't really help us. That's the hypotenuse of triangle number 1, but then that's the shorter leg of the bigger triangle. Now, if we were to go back, NP is the longer leg in triangle number 3, if you look at it from that, right? So here's my bigger triangle. Now, if you need to, if you are like, what in the heck is she talking about right now? Redraw them. Okay, so this is the bigger triangle, triangle number 3. NP is that longer leg, and MN is the shorter leg. Okay, we want a hypotenuse over a long leg. So NP to PM. Okay. So now we're looking at the big triangle again. So NP is the long leg, but PM is the hypotenuse. But remember, we want hypotenuse over long leg. And since this is long leg over hypotenuse, that's not our answer. Now for number 4, the ratio of NP to PQ. So let's look at this one. I'm thinking we're given 2 sides to the number 2. So PN or NP is actually the hypotenuse of triangle number 2, and PQ is the long leg of triangle number 2. So that is what's our answer is going to be. Now I want to go back to triangle number 2, choice number 2 really quick. Now originally I had written hypotenuse here like an H, like it was the hypotenuse of the triangle number 2, but then I switched it to long leg. And I did that because here's the thing. I was given 2 of the 3 sides of the bigger triangle. So you always want to look at for these types of questions, whether you're going to use triangle number 1, triangle number 2, or triangle number 3, you need 2 sides for the triangle. Okay? And since I had the 2 sides, since I was given the 2 sides in the choice for triangle number 3, that's why I switched it to triangle number 3. Okay? All right, so that was kind of a lot. We'll do more questions like that, but let's go to the next page. All right, so the next 2 questions are examples like what I was talking about of when they didn't give us a diagram and we're going to have to draw it. So looking for those keywords: altitude, hypotenuse, right triangle, right angle. That's important to look for those keywords. Okay. So in right triangle, QRS, angle R is a right angle. Now you're asking yourself, how do I set up a picture? Well, we'll do it together. So a right triangle, now you're going to draw a right triangle kind of like this, where the hypotenuse of the big triangle is on the bottom. Now it's important that we set up your letters carefully, right? Because then that just like throws off the entire question. Okay. So angle R is the right angle. So angle R is going to go up here. Now hypotenuse, the QS is the hypotenuse. Now it doesn't necessarily matter where those go as long as QS is the hypotenuse. All right. Now the altitude is like this, is RT. So T is here. Okay, so if QR is 20, QS is 25, so this whole thing is 25, then we want to find the length of QT. All right. All right, so now here's the thing with this one. I want to find QT. So that's the shorter leg of number 2. Now, if I cover this up for a minute, do you guys see how QR is the hypotenuse of triangle number 1? Right? Now, I was given 2 sides in the bigger triangle, so I'm going to cover up number 2 so you guys don't get confused. I was given QR, which is the shorter leg of the third triangle, and I was given QS, which is the hypotenuse of the bigger triangle. So I'm going to use triangle number 1, triangle number 3, and the proportions, whatever, is going to be short leg over hypotenuse is equal to short leg over the hypotenuse. Now you can do hypotenuse over short leg. That is totally fine. This is just what I'm going to use. Okay. So short leg of triangle number 1 is X. That's what we want to find. Hypotenuse of triangle number 1 is 20. Short leg of triangle number 3 is 20. And then hypotenuse of triangle number 3 is 25. So X times 25 is 25X is equal to 400. So now X is equal to 16. So the length of QT is equal to 16. Okay. Now, at any time, if this short leg over hypotenuse, all that proportion does not make sense to you, you are more than welcome to, by all means, draw the 3 triangles separately so you guys can see it better. All right. Okay, so let's look at 5. So the altitude, again, altitude, hypotenuse, right triangle, look for those key words. So if the altitude drawn to the hypotenuse of a right triangle, EFG partitions it into 2 segments of lengths 8 and 10, and we want to find the length of the longer, blah, blah, blah. All right, so let's draw our picture. All right, so now we need to figure out what is our right angle. So F is our right angle. Okay, so altitude of lengths 8 and 10. Then we want to find the longer leg of EFG in simplest radical form. So we're going to call this X. Now, it seems to me, in this case, it doesn't really specify which one's the right angle, and so it may not matter. But as you guys can see, this is triangle number 1, this is triangle number 2, and then obviously the whole big thing is triangle number 3. So kind of like the one we did above, we were given we were given one side of the smaller triangle and we're trying to find the hypotenuse. And then in a way we were given the whole hypotenuse because 8 plus 10 is 18. And we want to find the, oh crap. Oh, no. This is, never mind, I lied. The longer leg. So we are trying to find not EF, but FG. Excuse me. This is the short leg of triangle EFG. This is the longer leg. All right, so we're not using triangle number 1. We are using triangle number 2. So this is the hypotenuse of triangle number 2. And this is the longer leg of triangle number 3. This is the longer leg of triangle number 2. And this is the hypotenuse of triangle number 3. All right, so we're going to do long leg over hypotenuse of triangle number 2 and long leg over hypotenuse of triangle number 3. Okay? All right, so the long leg of triangle number 2 is 10. The hypotenuse of triangle number 2 is X. That's what we want to find. Long leg of triangle number 3 is X. And the hypotenuse of triangle number 3 is 18. Remember, it's that 8 plus 10. It's this whole thing. All right. Okay, so we have x squared is equal to 18 times 10, which is 180. Now square root. Now they said we have to leave it in simplest radical form. So 1, 4, 9, 16, 25, 36, 49, 64. All right, so I believe 36 goes into 180 5 times. So the square root of 36 is 6, square root of 5, and that is my answer. All right. All right, so last one, let's look at 6. So in the diagram shown, altitude AC is drawn from a right angle to BD in such a way that the ratio of BC to DC is 4:1. We want to find the length of DC algebraically. Okay. Now, remember, whenever we have these like ratio questions, we throw an X onto it, all right? So BC has 4, so 4x, and then DC has 1, which is x, and which is what we want to find. All right. So now this is triangle number 1, triangle number 2. Now we were given 2 sides for triangle number 1 and 2 sides for triangle number 2. So we're going to use triangle number 1, triangle number 2. So this is the short leg and then long leg of triangle number 1. This is short leg of triangle number 2 and long leg of triangle number 2. Okay, so short leg over long leg is equal to short leg over long leg. All right, so x over 12 is equal to 12 over 4x. Okay, so x times 4x is 4x squared is equal to 144. Divide by 4 first. So x squared is equal to 36, square root, so x is equal to 6. So the length of DC is equal to 6.